Okay, this time I've got a Rankine cycle with a reheat in it. Okay, and I've given some properties here. I've got isentropic efficiencies and everything of 80%. Okay, so state one going into the turbine, I have the pressure and the temperature. Okay, and again, what I will do is assume isentropic to find the best case scenario of state two, which will be S2S, gives me H2S, and then from that, then using the 80% efficiency, I'll find the actual H2. Okay, so I first need to look up my enthalpy and my entropy at state one, which is at 10 megapascals and 480 degrees. So 10 megapascals, 480 degrees. Do some interpolations in here, and I get for H, I get 331. Oh, that's 10 bar, not 10 megapascals. There we go. 480. There we go. 3321.4 right there, and my enthalpy is 6.5282. Okay, so go ahead and jot those guys down. So that's going to be 3321.4, and then my entropy is 6.5282. 6.5282, which again I use to find my isentropic enthalpy for the first stage of the turbine coming out here, where it comes out at basically 7 bar. Okay, so I'm going to go into 7 bar, okay, which is right here, and I'm at 6.5, so I'm below that, so I'm in saturation. So I go to 7 bar, and I do my interpolation. It's pretty close to this. So I get right here, I get an H value. This would be the idealized H value of 2684.8. Okay. And then what I'll do is I use my turbine efficiency, okay, to calculate H2, which again is what I'm actually getting out of the turbine divided by my best case, my isentropic turbine work. Okay, and again, what I know is this is 80%. So from that, I'll be able to calculate H2, knowing H1, H2S, and I calculate H2 to be 2812. So again, that's what I actually get as compared to this, which is the best case scenario. I'm 80% of that delta H. Okay. State 3, again, it's reheated to 480 when it comes through here. So again, I'm going to do the exact same thing. I'm going to look up H3, S3, and then use S3 to find the best case over here, S4S, which would then give me H4S, which will ultimately give me H4. So let me go ahead and look up H3. So again, I'm at 7 bar and 480. So 7 bar, 480. I have to do a little bit of interpolation, and I get that to be 3438.9 and 7.8723 for my S. Okay, so I'll go ahead and jot those guys down. So that H is 3438.9. And my S3 is 7.8723, which I'm going to use to figure out my isentropic case, my best case scenario over here for the second stage of the turbine. So I'll go to 6 kilopascals, okay, which is right here, and I'm at, what was I at, 7.8, and you can see I'm definitely below the 8.3, so I'm in between here. So I use that to figure out my best case scenario for my H value, which is going to be 2425.6 when I do the interpolation between these two values. Okay, so that's 2425.6. Okay, and then I'm going to use another turbine efficiency. This time it'll be basically H3 minus H4 all over H3 minus H4S, and again, I'll use that to find actual, because again, this is the isentropic case. I need to find what I'm actually doing, which is 80% of that. Okay, so that H4 is 2628.3. Okay, so that gives me that state. Now, going to state 5, again, coming out of the condenser, I know the pressure, I know it's a saturated liquid, so I can just look up H5, and then with the pump, I'm going to use the volume times the change in pressure equals the change in enthalpy. That's to find the best case. That's an isentropic pump. So I need to figure out my volume at state 5 as well. So I go back in, and I say, okay, at 6 kilopascal, my volume is 0.0010064, and my enthalpy is 151.53. So I'm going to go ahead and jot those down. So that was 151.53, and that was 0.0010064, I believe. .0064. Okay. Now from that, again, I'm going to use the isentropic case to help me find H6S, and that is given by V5 equals P6 minus P5, and again, this is for the work of a pump, which also equals delta H, right? This is, again, the work of an isentropic pump, okay? So I know my pressures, I know my volume, I know H5. From this, I can calculate H6S, and I find H6S as 161.59. Now that I have that, I can use that 80% efficiency to calculate my actual H6, where I'm going to use my pump efficiency, which for the pump efficiency, it's the idealized case divided by the actual case. Again, I know I'm at 80% here. So I use that, and I can calculate what I actually have for H6, which is going to be just a little bit higher, which is going to be 164.11. Okay, so again, I go and I figure out all of my H's, again, using isentropic efficiencies and things of that nature. Once I get that, I can go ahead and find my thermal efficiency once I've set all of my H values. Okay, so again, that's going to be the work of the cycle all over Q in. Okay. Now, work of the cycle, I actually have 2 turbines here. So that's going to be H1 minus H2 plus H3 minus H4, right? Because I have this turbine and this turbine. And then I go ahead and subtract off the pump, which is going to be minus H6 minus H5. And that's going to be divided by my Qin. Again, I have 2 Qins here. I have H1 minus H4, right, going through here, and then I have my reheat, so that's going to be plus H3 minus H2. And again, I've got all of these H's over here, so I can just plug those in over here to figure out my efficiency, and my thermal efficiency comes out to be 34.5%.